Hello, 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 ladies and gentlemen, and welcome back. In this video, we're looking at question 23 on our 2012 Cayley paper. In the diagram, points P, Q, and R lie on a circle with center O. This circle has a radius of 12. Point S lies on OR. OR, by the way, and OP, these are radiuses, so is this one here, so we can even draw those in. So S lies on OR, and it looks like we've got a right angle here, and I covered it up at an angle of 135 degrees. We want to know the area of the trapezoid, and we just want to know its closest to, which suggests to me I may wish to have my calculator handy. But we'll see. We'll see, won't we? Okay. So let's draw this picture. A nice little right angle there. 12 in total here. 12 here. 12 here. Now, how do you find the area of a trapezoid? Even if we just want to approximate it, well, we need to know the height of the trapezoid. I'm going to highlight my trapezoid in red. Okay. So we need to know the height of the trapezoid. You also need to know the lengths of the parallel sides, so this B and this A here. Okay. Now with that 12, with both of these 12s here, I realize that this side and this side give me an isosceles triangle. So this angle here is the same as this angle here, and that this might be helpful for us. Okay. Now, what else do we know? Well, we got another right angle up here. Okay. So this dot, this blue dot, which I'm now making a black dot, you got a 90 minus this dot here, but inside the triangle OQS, it's a right angle triangle, so we've got dot down here as well. Interesting. Okay. And what's more, since it's a quadrilateral, the sum of the angles inside a quadrilateral are 360 degrees. I've got 90 and 90, that makes 180. This whole thing is 135. And so this up here, what plus 135 is equal to 180? The remaining 180? 45. So this is 45, and this is 45, and this is 45. So we actually understand the angles in our shape a little bit better. And if we've got 45 here, to make 135, we must have a right angle here. So I've got two isosceles right angle triangles. So it's not just that this is A, it's the same as H, whatever H is. Okay? Now, one of the nice things about isosceles right angle triangles, if you know their legs, call them x here, you can use the Pythagorean Theorem, x squared plus x squared, and you can get the hypotenuse's square is 2x squared, so this must be root 2 times x. Okay? Or if I know the hypotenuse is root 2 times x, I can divide by root 2 and get x, these legs. So what triangles have we got? Well, we've got this OQS triangle. It's got 12, and the height and the other, and the shorter base, well, those must be 12 over root 2. I got 12 over root 2, 12 over root 2. Then we've got this one up here with B. It's an isosceles right angle triangle. The legs, the non-hypotenuse sides. And so we could either use the Pythagorean theorem, or we could just use this nice little observation and see that this should be 12 root 2. Okay, great. Now, a quick thing to note, just before we continue working on here. 12 is 6 times 2. Shocking, I know. But 2 divided by root 2 is just root 2. So 12 over root 2 is just 6 root 2. So if I draw my trapezoid again, I get 6 root 2 for the height, 6 root 2 for this base, and 12 root 2 here. Now the area should be 1/2 height times the sum of the two parallel sides. Okay. 1/2 times 6 is 3, so we get 3 root 2. 6 root 2's plus 12 root 2's is 18 root 2's. 3 and 18 is 54. Root 2 times root 2 is 2. So we can actually figure out the area of this trapezoid exactly. It's 108. Is that a possible answer? Absolutely it is right there. I think this answer 216 is for the people who forget trapezoid areas are a half. Half. Okay? So we get an answer of C, 108. Isn't that nice? Nice little question. So we actually didn't need to bust out the calculator at all. We were able to calculate it exactly. Fantastic. Okay, so we got 2 more questions to go on this Cayley paper. Up next, of course, question number 24. Thank you guys so much for watching. I'll see you for more math next time.